Okay, so now we're gonna do question 1. In 1.1.1, we're going to solve for x for this problem here. So we have x squared minus 4x minus 21 is equals to 0. So the first thing we're going to do, we're going to find factors of x squared, which is x and x, factors of 21 such that they give us the middle term. It's going to be 7 and 3. Then the 7 takes the sign of the middle term, which is negative, and then the 3 takes the positive sign. So it's going to be equals to 0, and then we have x plus 3 equals to 0, or x minus 7 is equals to 0. Then we transpose the 3 to the other side, and this minus 7 to the other side. We have x is equals to minus 3, or x is equals to 7. So these are your solutions of x. Okay, right. Now we're gonna do 1.1.2. Okay, so we have x into 5x minus 1 equals to 3. So the first thing we're going to do is we're going to multiply the x inside. So it's going to be 5x squared minus x equals to 3. Transpose the 3 to the other side. We have 5x squared minus x minus 3 equals to 0. So because we can't factorize the expression, we're going to use our quadratic formula, which is minus b plus minus root of b squared minus 4ac over 2a. So x is equals to minus, our b is equals to minus 1, so it's minus 1, plus or minus root of minus 1 squared minus 4. Our a is 5, so it's going to be 5, and our c is minus 3. And then we divide by 2 into a, which is 5. Then our solutions of x, because we're required to write in 2 decimal places, so it's going to be 0.88, or x is equals to minus 0.68. So these are your solutions of x. Now we're going to solve 1.1.3. Okay, so we have 2x squared minus 9x plus 4 is greater or equal to 0. So the first thing we're going to do is we're going to factorize. Greater is equal to 0. The factors of 2x squared, we have 2x and x. Factors of 4 such that when you add and subtract, they give you the middle term. So it's going to be 4 and 1 here. So it's negative and negative. Then because we have our inequality here, means that we need to find our critical values. So it's going to be 2x minus 1 equals to 0. Or x minus 4 equals to 0. Then you transpose the 1 to the other side. You have 2x equals to 1, or x equals to 4. Then you divide by 2 both sides. You have x equals to 1 over 2. So you have 2 critical values here. So what you're going to do is you're going to represent them in your number line. You have your 1 over 2, and you have your 4, and then you're going to test values before your critical value. So this is your critical value, and this is your critical value. So you're going to test values before your critical value, which can be your minus 1, and value between your critical values, which can be your 2, and values after your critical value, which can be 5. So you need to test these values here and substitute them in your standard form of equation of 2x squared minus 9x plus 4. So you substitute where there's x, you substitute these values here. Then the signs that you're going to get, because we're interested in the signs and not the solution. So the sign that you're going to get before this critical value of half, you're going to get a sign of positive. And then when you substitute the value of 2 inside your equation, the sign you're going to get in this case is a negative here. And then just after your critical value of 4, which is 5, so you're going to substitute it into the equation, and you will find the sign of positive. So these signs tell you that there's solutions of y are positive when x is equals to negative. Solution of y is negative when x is equals to 2. solution of y is positive when x is equals to 5. So we need to go back to the equation and see what is the requirement of the equation. We want solutions of x such that the solutions of y are greater or equal to 0. So we're going to focus on positive signs. So meaning that now that we know that we want to look at the positive signs, which means we have our shaded, since it's greater or equal to 0, we're going to have our shaded point facing the positive solutions. So we have our shaded point facing the positive solutions. Then we can confirm now that since our solutions are facing the positive signs, we can say x must be less than or equals to 1/2, or x must be greater or equals to 4. So these are your solutions of x for this problem. Now we're going to solve 1.1.4. Now we are having 3x plus 1 minus 3x minus 1 minus 24 equals to 0. So the first thing is we're going to break down. So it's 3x multiplied by 3 to the power 1 minus 3 into the power x multiplied by 3 to the power minus 1 minus 24 equals to 0. Then we use the value of k, so we let k be equals to 3 to the power of x because it's common throughout, and then we substitute that value of k, so it's going to be 3k minus 3 to the power of minus 1k minus 24 equals to 0. And we need to write this expression in proper form, so it's going to be 3k minus k over 3 minus 24 equals to 0. Then we're going to cross multiply, or let me say we're going to multiply out the 3, and then we'll have 9k minus k minus 24 times 3 equals to 0. So 9k minus k is going to give you 8k minus 72 equals to 0. Then we're going to transpose the 72 to the other side. You have 8k is equals to 72. Divide by 8 both sides. We're going to have k equals to 9. But you need to remember that we said k is equals to 3 to the power of x. So where there's k, we're going to put 3 to the power of x. So it's going to be 3 to the power of x is equals to 9. But 9 can be written as 3 to the power of 2. So we're going to have 3 to the power of x equals to 3 to the power of 2. Then we have same basis, we're just going to drop the exponent, so x is equals to 2. So this is our solution of x. So 1.2, we need to solve for x and y using these two equations here. Then we have y plus 2x is equals to 2 as our first equation. And we have y squared minus 3yx is equals to minus 2x squared as our second equation. So to solve for x, we need to first identify our equation 3. So we will use this one because it's simpler. And we're going to have y is equals to 2 minus 2x as our third equation. So the first thing we're going to do is we're going to substitute equation 3 into equation 2. So wherever we see y, we're going to replace it with 2x. So wherever we see y, we're going to replace it with 2 minus 2x. Alright. So the first thing we're going to do is we see y squared here. So it's going to be 2 minus 2x squared minus 3 into 2 minus 2x multiplied by x is equals to minus 2x squared. So what we're going to do is we're going to expand this expression. So it's going to be 2 minus 2x, 2 minus 2x, minus 3 into 2 minus 2x multiplied by x equals to minus 2x squared. Then we will find the product of this expression here. So we're going to multiply out using our FOIL method, and we'll have 4. Then we're going to have 4, which is this 2 multiplied by this 2 is 4. Then this 2 multiplied by this other 2 is going to be minus 4x, and then minus 4x plus 4x squared. So what's going to happen is we're going to multiply this x inside here, and we're going to have minus 3 into 2x minus 2x squared equals to minus 2x squared, and then we're gonna collect like terms for this part here. So we're gonna have 4 minus 8x plus 4x squared, and then this 3 will multiply everything that is inside. We have minus 6x plus 6x squared. Transpose the 2 to the other side. It's going to be positive 2x squared equals to 0. And then we're going to collect like terms. So this 4x squared and this 6x squared and this 2x squared, we're going to write it in one side. So it's x squared plus 6x squared plus 2x squared. Then we're going to collect like terms of these two here. So it's going to be minus 8x minus 6x, and then we plus the 4 equals to 0. So when we add these three like terms here, we're going to have 12x squared, and these two like terms, we have minus 14x plus 4 equals to 0. And then we're going to divide by 2 all sides just to simplify the problem. So we will have 6x squared minus 7x plus 2 equals to 0. Now we're going to find the factors of this problem here. So the first thing is we find the factors of 6x squared, such that those factors help us in with the factors of 2, and then making sure that we at the end of the day we get the middle term. So if we use 3x and 2x here, and then we say the factor of 1 here and 2 here, so what this means is when you multiply this 3 with this 1, you're gonna get 3, and when you multiply these 2 and this 2x, you're gonna get 4, right? When you add the 3 and the 2, it gives you the middle term of 7. So those factors are correct. Then we put the signs inside, so it's going to be minus here and it's going to be minus here. So 3x minus 2 equals to 0, or 2x minus 1 is equals to 0. Transpose the 2 to the other side, you have 3x equals to 2, or 2x is equals to 1. Divide by 3, divide by 3. Here divide by 2, divide by 2. So x is equals to 2 over 3, or x is equals to 1 over 2. So these are your solutions of x. Remember that your equation of y is equals to 2 minus 2x, which is your equation 3. So what we're going to do is we're going to say y is equals to 2 into 2. Then we substitute this x here, which is 2 over 3. Or y is equals to 2 minus 2 into, we substitute this x here of 1 over 2. Then we have y is equals to 2 over 3, or y is equals to 1. So these are our solutions of y, and these are our solutions of x. 1.3, we are going to simplify this problem here without the use of a calculator. So we're going to simplify this problem here. So if you write it properly, it's a 4th root, and then it is square root of 20 minus square root of d of x of 4x, right? And it multiplies the same expression, 4th root of 20 minus plus the root of d of x of 4x. So what we're going to first do is, because it has the same 4th root, so we're going to use 1 4th root for the entire problem. Remember that when you have the root of 2 multiplied by root of 2, we're just going to say a root. We're going to take this root as 1 because it has same squared roots, so we're going to multiply what's inside. So we're doing the same concept here. So I'm just going to multiply what's inside. So we're going to say root of 20 minus root of d of x of 4x, and then we multiply it with root of 20 plus root of d of x of 4x. Then now we're going to write our 4th root, and then we're just going to multiply what's inside. So before you multiply what's inside, let's first deal with this d of x of 4x. So what this means is, if we have d of x of 4x, it means we need to derive what's inside the brackets. So when you derive 4x, it gives you 4, right? So that's what we're going to put inside here. So it's going to be your bracket and root of 20 minus root of 4. Then you close your bracket, open to the other side. You have root of 20 plus root of 4. Then you close your bracket. So now because this expression here, so remember that this is 4. Let me write it nicely. So it's going to be 4. So now remember that if you have a difference of two squares, x squared minus 1, so when you factorize it, it's x plus 1, x minus 1. So as you can see, this expression is factorized the same way as this one. We just need to find solutions as a difference of two squares. So you're just going to multiply this with this, and we're going to get the fourth root of, so when you multiply a root of 20 and a root of 20, you're just going to get 20, and then you're just going to multiply the root of 4 and the root of 4, and you're going to get 4. So multiply the root of 20 and the root of 20, you get 20. Multiply the root of 4 and the root of 4, you get 4. So then you have a fourth root of 20 minus 4, you're going to get 16, and the fourth root of 16 is going to give you a solution of 2. So now looking at question 2.1 says that given the quadratic pattern of minus 22 minus 12 minus 6 and minus 4. So in 2.1.1 we are asked to write down the next two terms of the pattern. So we need to find the next two terms of the pattern. So to find the next two terms, we have minus 22 and minus 12 minus 6 minus 4. So we need the next two terms of the pattern. So the first thing we're going to do is we're going to find the difference of these numbers here. And the first difference you're going to have is 10. The second difference is 6. The third difference is 2. Then we find the second difference of the sequence, or the pattern rather. The second difference is going to be minus 4. So as you can see, it's common throughout. So it means that it's going to be common here, it's going to be common here. So what you need to do is we need to find the terms of the first difference here. So how we're going to get them is we're going to say this minus 2. So to find them, we're going to say that this 2 here plus this minus 4 is going to give us what? It's going to give us minus 2. And we're going to add this minus 2 with this minus 4 to get a solution of minus 6. Then now to find these terms here, we're going to say minus 4 plus minus 2 is going to give us minus 6 here. And this minus 6 plus this minus 6 is going to give us minus 12. So your next two terms is minus 6 and minus 12. 2.1.2, we are asked to find the expression of the nth term of the pattern. To find our nth term, we need to first write down our sequence that we wrote in the previous question. So we're having our sequence here, and our first difference of the sequence is 10, 6, 2, minus 2, minus 6. And the second difference of the sequence is minus 4. So minus 4 is constant throughout. So to find the nth term, we're going to say 2a is equals to the second difference, which is minus 4, divided by 2 both sides, and then a is equals to minus 2. Then 3a plus b is equals to the first term of the first difference, which is this 10 here. So it's going to be 10. Then you know our a is equals to minus 2, so 3 into minus 2 plus b is equals to 10. Then we transpose this portion here, which will give us a solution of 6 plus b is equals to 10. Transpose the minus 6 to the other side. We have b is equals to 10 plus 6. Then our b is equals to 16. Then now what you're going to do is going to say a plus b plus c is equals to our first term of the pattern, which is minus 22. So it's equals to minus 22. So where we substitute for, so now the value of a is minus 2, so it's going to be minus 2 plus the value of b, which is 16, so it's plus 16 plus c is equals to minus 22. Then you transpose these two values to the other side, and the solution of c is going to be equals to minus 36. So now we're having our value of a, which is equals to minus 2. We have a value of b is equals to 16, and our value of c is equals to minus 36. Remember that our Tn is equals to an squared plus bn plus c. So we're going to substitute our values. So a, we're going to say minus 2n squared plus 16n minus 36. So this is the nth term of the number pattern. In 2.1.3, we are asked to write down the term of the pattern which has a maximum value. So now we are asked to find a term that has a maximum value. So what we need to do is we need to first write our nth term, which is minus 2n squared plus 16n minus 36. So to find the n value at its maximum, normally we use our turning point, which is equals to minus b over 2a. Why are we using our turning point? Because we're talking of a maximum value. And remember that when you talk of maximum or minimum, and looking at this, it is an equation of a parabola. So if you draw your parabola like this parabola has a minimum value here at y, right? And if you draw a parabola looking down like this, it has a maximum value. So the minimum and maximum is defined by your value of a. So if a is less than 0, then your graph of a parabola will have a maximum. If your a is greater than 0, then your parabola will have a point of minimum. So our parabola here is a point of maximum because our a value is less than 0, which is a is equals to minus 2, as you can see here. So we're going to find the value of n when the graph is at a point of maximum. So it's going to be x is equals to minus, so our b is 16, and divide by 2 into our a, which is minus 2. So our x values, we're going to get 4. So meaning that n is equals to 4 when this graph is at a point of maximum. In 2.2, we are given the nth term as Tn is equals to 27 minus 6 into n plus 1. So we are asked to find the common difference of the term. So we're having Tn is equals to 27 minus 6 into n plus 1, and we're asked to find our common difference. Just take our common difference, which is this one, because it always multiplies our equation here. So which you can simply say d is equals to minus 6, which is your common difference. In 2.2.2, we need to write down the term of the sequence that is equals to minus 117. So now what you're going to do is we are given Tn as minus 117, and we have our Tn, which is 27 minus 6 into n plus 1. To find the n value, we're going to equate the minus 17. So it's minus 117, sorry, equals to 27 minus 6 into n plus 1. Then you're going to transpose the 27 to the other side. We have minus 117 minus 27 is equals to minus 6 into n plus 1. Then you're going to divide by minus 6, divide by minus 6. We have n plus 1 is equals to minus 117 minus 27 over minus 6. Then what you need to get is you're going to say n equals to, so you're going to transpose the 1 to the other side. You have minus 117 minus 27 over minus 6 minus 1. So your n value is going to be equals to 23. So now in 2.3, we are given the series here of 5, 9, and 13, which consist of n terms. The sum of the last 6 terms. So the sum of the last 6 terms of the series is 906. So in 2.3.1, we are asked to determine in terms of n the sum of the n terms of the series. So you're going to find the sum of n terms of the entire series. So here what we're going to do is we have our series, which is 5, 9, and 13, right? So to find our sum of n terms, what you're going to do is we're going to first find the difference of this sequence here. And the difference that you're going to get is 4, which is common throughout. So our sum of the series is equals to n over 2 into 2a plus into n minus 1d. So why is this? Are we using this sum? Is because we have identified that this series here is arithmetic. Right, so if it's arithmetic, how do we see that? We see it with this common difference. And so what you're going to do is we're going to substitute into our sum here. So we don't have our n, so it's going to be n over 2 into 2. Instead of writing a, we're going to write this 5 here. So it's going to be 5 plus into n minus 1. Our d is going to be 4. So what you're going to do is we're going to multiply everything, but before we multiply everything inside, let's solve everything inside here. So we're going to have equals to n over 2 into 2 multiplied by 5 is going to be 10, and then the 4 we multiply everything that is inside, so it's going to be plus 4n minus 4, and then we have equals to n over 2 into, so we're gonna add and subtract this. 10 minus 4 is going to give you 6 plus 4n, and then you multiply the n over 2 inside, so we're going to have 6n over 2, right, plus 4n squared over 2. So your solution of your sum is going to be 3n plus 2n squared. So this is our sum of n terms. 2.3.2 says that if the last 6 terms of the series are excluded, determine in terms of n the sum of the remaining terms. So now if they say that the sum of 6 terms which are excluded, which is equals to 906, and to find our solution here is we're gonna say the sum of n minus 6, so we are subtracting the 6 terms. It's gonna be equals to our sum that we found in a previous question minus the sum of 6 terms that are excluded. So meaning that the sum that we found in the previous question was 2n squared plus 3n, and then we subtract the 6 terms, which is we're gonna just subtract with this number here, so it's gonna be minus 906. So this is the sum of n terms minus the 6 terms. 2.3.3, hence determine the value of n. Now we want to find the value of n. For us to find the value of n, we need to first write our sum excluding the 6 terms, right? So how do we find it? We found that in the previous question to be 2n squared plus 3n minus 906, right? So let's consider this as our equation 1. Why? Because we can still find the sum of n minus 6 in another way. So what we want to do is we're going to say the sum of n minus 6 is equals to, we're going to substitute that in our sum, which you remember very well that our sum was equals to 2n squared plus 3n. So we're going to say the sum of n minus 6 is equals to 2 into, so instead of writing this n squared, we're going to say n minus 6 squared plus 3 into n minus 6. Then we expand this expression, so it's n minus 6 plus 3 into n minus 6. Then we're going to find the product of this expression here. So it's going to be 2 into n squared minus 6n minus 6n plus 36, plus, then you multiply the 3 inside, you will have 3n minus 18. So the sum of n minus 6 is equals to 2 into n squared minus 12n plus 36 plus 3n minus 18. So when I multiply the 2 inside, we're going to get 2n squared minus 24n plus 72 plus 3n minus 18. Then we're going to collect like terms, so it's going to be 2n squared, then you collect the like terms, these two, minus 24n plus 3n, and then these like terms here, so it's going to be plus 72 minus 18. Then your sum of n minus 6 is equal to 2n squared minus 21n plus 54. So this is your sum of n excluding the last 6 terms. So let's equate this to equation 2 because we already have equation 1. So what we need to do is we need to equate equation 1 with equation 2. Remember that equation 1 was Sn minus 6 equals to 2n squared plus 3n minus 906. See, this was equation 1. So let's equate these two equations here. So equation 1 is equals to equation 2. So because we want to find the value of n, hence we are equating them. And they are equal since it's the sum of n minus 6. So the first equation is going to be 2n squared plus 3n minus 906 equals 2. And then our second equation is going to be and then our second equation is what we just found here, this one here. So it's going to be 2n squared minus 21n plus 54. So what you're going to do is, this is the like term of this one. If it's transposed to the other side, it's going to be negative, so they're going to cancel out. Then you collect these like terms here, so you transpose the minus 21 to the other side, you have 3n plus 21, and then you transpose this 906 to the other side, the negative 906 will have equals to 906 plus 54. And then if you add these two, you're gonna get 24n is equals to 960. Then you divide by 24 both sides, you have n is equals to 40. So these are your number of terms. So now in question 3.1 says that we are given this geometric series of 3, 3 over 2, and 3 over 4. Determine the largest value of n such that Tn is greater than 3 over 16384. So the first thing we're going to do here is we're going to write our series, which is 3, 3 over 2, 3 over 4. So this is the first 3 terms of our series, right? Our geometric sequence. So now since we are told that it's a geometric sequence, we're going to find our common difference, which is t. So we're going to find our common difference, which is r. So knowing that this is a geometric sequence, we need to find our common difference. So r is equals to t2 over t1 is equals to t3 over t2. So if you divide 3 over 2 by 3, which is equals to 3 over 4, divide by 3 over 2, you should get your r as 1 over 2. So this is your value of r. So but consider that the question says that we must find the value of n when Tn is greater than 3 over 1, 6, 3, 8, 4. So we need to first find this Tn here. So the Tn of a geometric, it's ar to the power n minus 1, and our value of a is this 3 here. So it's going to be 3 into our r, which is 1 over 2 to the power n minus 1. So this is our Tn. So we're going to replace it here. So we're going to say 3 into 1 over 2 into n minus 1 greater than equals to, sorry, so it's greater than, sorry, so it's greater than 3 over 1, 6, 3, 8, 4. So to find the value of n, what the first thing we're going to do, we're going to divide by 3 both sides, and the 3 will cancel out with this 3 here. So we'll have 1 over 2 to the power n minus 1 greater than 1 over 1, 6, 3, 8, 4. Just to explain how this 3 will cancel out the other 3, so it's going to be 3 over 1, 6, 3, 8, 4, divide by 3, and then we have 3 over 1, 6, 3, 8, 4. We're going to change the sign from divide to times, so this 3 is going to tip. It's going to be 1 over 3, so this 3 will cancel out with that 3. Fine. So to find the value of n here in this problem here, we're just going to say n minus 1. We're going to use logs greater than log of base 1 over 2, which is our base, and then we multiply with 1 over 1, 6, 3, 8, 4. So n minus 1 is greater than, we're going to get 14, and then we transpose the 1 to the other side, n is greater than 15. So this is not necessarily a solution. N is not greater than 15. Why am I saying that? If you have your Tn equals to arn minus 1, which we found to be 3 into 1 over 2 to the power n minus 1, right? But the question says that we must find the value of n when Tn is actually greater than 3 over 1, 6, 3, 8, 4, right? So if you substitute here, n is equals to 16 maybe, because we found n greater than 15, you're going to get, so if you say 3, 1 over 2 to the power 16 minus 1, you're going to get a solution of, you're going to get a solution of 3 over 3 to 7, 6, 8. So this value here is actually less than this one here. So your Tn is not greater than this expression here. So this value is smaller compared to this value here. So we need a value that is larger, right? So if you substitute 3 into 1 over 2 to the power of 14 minus 1, you're going to get a value of 3 over 8192. So this is a correct solution because this expression here is larger than this expression here. So you can confirm or conclude rather and say, well, n must be equals to 14 to get the expression that is larger than 3 over 1, 6, 3, 8, 4. So now in 3.2 we are asked to find the value of p when these two sums are equal. So we are given that the sum to infinity when k is equals to 1 of 27p to the power of k is equals to the sum of 30 terms when n is equals to 1 of 3 into 1 over 2 to the power of n minus 1, right? So what we're going to do is we're going to first find the three terms of this sum to infinity, so that we'll be able to identify the sum of the sequence, the sum to infinity. So first find the three terms for this one, and then for this one here, if you take a look, it's actually similar to the previous problem that we just did. If you look at this portion here, so you don't need to find the first three terms because we already know them. We know that it's equals to 3 over 2 and 3 over 4, and our r we found to be 1 over 2. We already know our r, we already know our a, which is equals to 3. So, and what we need to note is we will find our n very easily, because n is equals to top minus bottom plus 1. So n is equals to our top value, which is 30 there, minus our bottom, which is 1, this portion here, plus the 1, so it's going to be 30. So we have everything for this side, and let's just find the first three terms of this one here. So it's going to be, when k is equals to 1, 27p to the power of 1 when k is equals to 2, 27p to the power of 2 when k is equals to 3, 27p to the power of 3. Right, we were substituting the k to this power here. So our first three terms of this sequence is going to be 27p plus 27p squared plus 27p cubed. Right, so our a value is equal to 27p, and then our r, because this is a sum to infinity, our r is going to be 27p squared over 27p equals to 27p cubed over 27p squared. So our r here is going to be p, because the p will cancel the p, remain with p, and the 27 will divide out. So your r is equals to p. So now to find the sum to infinity, which is equals to a over 1 minus r, our a value is the 27p, so it's going to be 27p over 1 minus our r is equals to p. So this would be your equation 1, the sum of infinity, right? And let's deal with the other portion. Remember that our sum here, we already know our r being equals to half. We calculated our n, which is 30, and we know our a value, which is 3. So we know very well that we are dealing with a geometric sequence, right? So to write that down, we have r is equals to 1 over 2, a equals to 3, and n equals to 30. So to find the sum of this geometric, so what you're going to do is you're going to say sum of 30 terms is equals to a. So to find the sum, we first write the equation of a geometric. So it's a into 1 minus r to the power n divided by 1 minus r. So the sum of 30 terms is equals to our a value, which is 3, into 1 minus into 1 over 2, which is our r to the power 30, divided by 1 minus 1 over 2. So if you punch your calculator, you're going to get an answer that approximates to 6. So simply write 6. So s of 30 is equals to 6, and sum to infinity is equals to 27p over 1 minus p. And remember that these two sums were said to be equal to each other. So meaning that you're going to say the sum to infinity is equal to the sum of 30 terms. So we want to find the value of p. Remember that. So the sum to infinity is equal to 6 equals to the sum of 30 terms is 27p over 1 minus p. Then we cross multiply, it's going to be 6 into 1 minus p equals to 27p. So we're going to multiply the 6 inside here, so it's going to be 6 minus 6p equals to 27p. Transpose the minus 6p to the other side, you have 6 equals to 27p plus 6p, right? And then 6 is equals to 33p, and then you divide the 33 both sides, you have p equals to 6 over 33. So if you simplify, it's actually 2 over 11. So this is your value of p. So now in question 4, we are given the function of f of x equals to minus 2x squared minus 4x plus 16. So 4.1, we are asked to find the y-intercept of f. So having f of x being equals to minus 2x. So having f of x being equals to minus 2x squared minus 4x plus 16. So the y-intercept when x is equals to 0, so you're going to substitute where you see x to be 0. So it's minus 2 into 0 squared minus 4 into 0 plus 16. So your f of x when x is equals to 0, it's 16. So this is your y-intercept. So now 4.2, we are asked to find the x-intercept of f. So your f of x being equals to minus 2x squared minus 4x plus 16. So the x-intercept when y is equals to 0, so it's going to be 0 is equals to minus 2x squared minus 4x plus 16. Then we divide by negative 2 all sides. We have 0 is equals to x squared plus 2x minus 8, right? So we're going to have 0 is equals to, we factorize this expression here, it's going to be x and x. We use 4 and 2. The middle term is positive, so which means the large term will be positive and this term will be negative. So x minus 2 equals to 0, or x plus 4 equals to 0. So x is equals to 2, or x is equals to minus 4. So these are your x-intercepts of f. So now in 4.3, we are asked to find the coordinates of the turning point of f. So having our f of x being equals to minus 2x squared minus 4x plus 16. So the turning point is x equals to minus b over 2a, which our b is minus 4 divided by 2, our a is minus 2. So your x value of the turning point will get minus 1, and then you substitute that x value of minus 1 to your original equation of minus 2 into, put minus 1 squared minus 4 into minus 1 plus 16. So you should get a value of 18. So this means now that your turning point is minus 1 and 18. Four point 4, we are asked to sketch the graph of f indicating all intercepts with axes and the turning points. So let's first write down our intercepts. We found that our y-intercepts, the coordinate is 0 and 16. So these are our y-intercepts. And then our x-intercept we found to be 2 and 0 and minus 4 and 0. So these are our x-intercepts, right? And our turning point we found to be minus 1 and 18. So to draw our function, it's going to look like this, and we indicate our turning point of minus 1. So meaning our minus 1 will be somewhere here, x equals to -1, and our 18 would be somewhere here. So this is our turning point. So our y is equals to 18. This is our turning point of -1 and 18. And our intercepts, we have x-intercept of 2 and 0. So meaning, let's say 2 is here. So it's 2 and 0. And another intercept of -4 and 0. So let's say it's here, which is -4 and 0. So we going to join our points. So its graph is going to look like this and like that. So we also need to indicate this intercept, which is our y-intercept. We found x to be 0, so it's going to be 0 and 16. So this is our graph of f of x. So now in 4.5 we are asked to write down the range of f. So when we talk of range, we talk of the y values. So we're gonna go back to our graph, right? And the range, talking about the y values, we want to know the movement of the y values. So if you look at this graph here, these are negative y values, these are positive y values. This is positive x and negative x. So looking at the positive y values, they come from a negative infinity and they go up to this maximum point of y is equals to 18, and then they from y is equals to 18 they go all the way to positive infinity. So the range, you can simply write so the range of this, you can simply write negative infinity going to 18 inclusive. So this is not inclusive, this is just a smooth bracket like that, and 18 to positive infinity. So you can simply write it like this, or you can simply write y is less than or equals to 18. So these are just two ways to write your range. Doing question 5, we are given a sketch with f of x equals to 1 over 2 all to the power of x, and g of x is written in this form. We are told that B is a point on the intersection of the asymptotes of G, and A is the y-intercept of f. The graph passes through the origin. AB is parallel to the x-axis. So this is your graph, as you can see. So what you're going to first do is, in 5.1, we're going to write down the inverse of f in the form y is equals to. So f of x is given as 1 over 2 all to the power of x. So to find the inverse, we first write y is equals to 1 over 2 to the power of x. Then we swap, where there's y we put x, where there's x we put y. So it's going to be 1 over 2 to the power of y, and then we write in standard form. So it's going to be y is equals to log base 1 over 2 multiplied by x. So this is going to be our inverse of f. So now in 5.2 we are asked to write down the domain of the inverse of f. So to find the domain, we know that our inverse is y is equals to log of base 1 over 2 multiplied by x, right? So which, if you were to draw this inverse, you're going to have something like this, looking like that. And what you need to note is this is y-axis, this is the x-axis. The x values, because we wanted the domain, so we're focusing on the x values. The x values don't necessarily touch the origin, so they don't necessarily touch this. When x is equals to 0, the graph doesn't touch, because this is where the asymptote moves, right? So but anything above x is equal to 0, the graph is moving, you know, it's passing through. So we can simply say the domain which the x values of this graph is greater than 0, because it will never touch the asymptote. So it's just going to be x greater than 0. So now in 5.3 we are asked to sketch the inverse of f, indicating all x's and asymptotes. So remember that our inverse is y is equals to log of base 1 over 2 multiplied by x. So we first have to find our x-intercept when y is equals to 0, right? So where there's y, we put 0 is equals to log of base 1 over 2 and x there. So this 1 over 2 is going to be to the power of 0 is equals to x, which is equals to 1, because anything to the power of 0 is 1. So the coordinates is 1 and 0 for our x-intercepts, and then our y-intercepts when x is equal to 0. So we have y is equals to log of base 1 over 2 multiplied by 0. So here you won't find a solution, so no solution. So means that your graph does not pass through this y-intercept. So meaning that now if you are now going to draw your graph, you have your graph there, and you know that it passes through a point of x which is 1 and 0, but it doesn't pass through your y-intercept. So this is your y-intercept, this is your x, so it's a y-axis and x-axis. So your graph is going to move like this, meaning that it won't touch your y-axis. So this is your inverse of f. 5.4, we are told that if h of x is the equation of one of the axes of symmetry of G, determine the coordinates of B. B is actually the intersection of our asymptotes, both vertical and horizontal. And so for us to find the points here, we need to first find this value of a here, right? This value of a lies in our graph of f of x, right? But remember the previous question, we found our inverse of f, which was moving like that, and we found this point to be 1 and 0. So what this means now is our value of a is going to be the inverse of this coordinate here, so it's going to be 0 and 1. So that is our coordinates of a, right? So looking at those coordinates, it tells us that our y is actually equals to 1, right? So it's moving like this, which is our asymptote, one of the coordinates of b. So meaning that if we want b, we know that x we don't know, but we know the value of y, which is 1, right? So it's going to be simpler now for us to find the x value of b. So having our h of x being equals to x plus 3 and our b being equals to into x and 1, so we want to find the x value now of b. So we're going to substitute this y value in our h of x. So we're going to put 1 instead of h equals to x plus 3. Transpose the 3 to the other side, we have x equals to 1 minus 3, and then x equals to minus 2. So this is the x value of our b. So if you write b, it's going to be minus 2 and 1. Now 5.5, we are asked to determine the equation of G. Remember now we have our intercept of asymptotes being minus 2 and 1. So it's going to be easier now to find our value of G. So our g of x being equals to a over x plus p plus q, and our value of b, which is the intercept of our asymptotes, minus 2 and 1. So this tells us that our vertical asymptote x is equals to minus 2, our horizontal asymptote y is equals to 1. So if we substitute in our equation of g, we have a over x plus 2 plus 1. So this is our graph, but it's not complete since we don't know the value of a. So we need to substitute a point to really find the value of a. Remember that our graph passes through a point of origin of 0 and 0. So you're going to substitute that point of 0 and 0. So it's going to be 0 is equals to our a value over 0 plus 2 plus 1. Transpose the 1 to the other side. Minus 1 equals to our a over 2. Cross multiply. So our a is equals to minus 1 times 2. So our a value is equals to minus 2. So to write down our equation, g of x is equals to minus 2 over x plus 2 plus 1. So this is our graph of g. So now we're going to do 5.6. We are asked to write down the equation of k such that k of x is equals to g of x minus 3 plus 1. So what you need to first do, you need to write our g of x, which is equals to minus 2 over x plus 2 plus 1. And we are told that our k of x is equals to g of x minus 3 plus 1. So our k of x will be equals to minus 2 over, so in our g of x we're going to substitute this value here. So we're going to substitute it here. It's going to be x minus 3 plus the 2 plus the 1, which is this one, and we're going to plus this one, which is 1. So our k of x is going to be equals to minus 2 over x minus 1 plus 2. So this is our equation of k of x. Now we're doing 5.7. Determine the values of x, or for which 5.7.1, when the graph of f multiplies the graph of g, gives you a solution of y which is less than or equals to 0. So it gives you a solution of y which is 0 or which is basically negative, right? So we need to look at that. So when does that happen? So you go back to your graph, you look for a point where when you multiply f and your g, you get a solution that is less than or equals to 0. So we're going to look at that. So this is our graph of f, this is our graph of g. So this part of the graph of f here, our y values are positive, right? Our y values are positive, going up they are positive. And then for our graph of g, our y values are negative here, going down they're negative, negative, negative. So when you multiply a positive with a negative, you get a solution of negative, right? So this is what we are looking for. We're looking for that situation where we multiply a positive and a negative, you get a negative. So this means now that we need to consider this part of the graph, but we can't consider the entire part. So if we were to consider, we'll consider this portion here of our f of x. Why? Because there's an asymptote here that is moving here of x equals to minus 2, right? Where it's just separating these two graphs. So we're just going to consider this portion here of f, and we're going to consider this portion here of g, so that when we multiply these two, they give us a solution of negative. So your solution of x now, you're just going to say when x is greater than minus 2, this positive y value multiplied by this negative y value will give me a solution that is less than or equals to 0. So this is the first solution of x, right? When x is greater than minus 2. Or someone can also look at it from this part of the graph, where this portion here for your g is actually positive. So your y values here are positive, going down like that, they are positive. And if we consider this portion of, so So another solution of x would be, you need to remember that we need to make sure now that, because after this point here, so after this point, everything within this point here is correct. So if you say x is greater than 2, it's correct. But after this point, our graphs come to a positive part of y, right? So our y's both are positive, so it doesn't necessarily qualify us into finding the solution here. So means that our our x values must be within the point of origin and x being greater than -2, right? So, or you can also say, or x must be less than or equals to 0. So when x is less than or equals to 0, the same happens where positive multiplied by the negative gives you a negative solution of y. So you can simply say, write down as x greater than -2, or x less than or equals to 0. Or you can simply say when x lies between -2 and 0. So both these solutions are correct. So now 5.7.2, we are asked to find solutions of x when the g prime of x is greater than 0. So what this means now is we want to know the values of x when the gradient of the g of x is positive, it's increasing. So this is our g of x, right? And this is also our g of x, right? So let's look at how it's moving. So our g of x is moving from the left to the right, right? So it's actually increasing. So the gradient is positive. Why? Because it's increasing. It's increasing from here, and it's separated by this asymptote here of x is equals to -2, right? So our graph is increasing. Even here, our graph is increasing from the left to the right hand side. Our graph is increasing. So how do we find the solutions of x when the g prime of x is greater than 0? So this means now that when x it's less than -2, which when it's less than this asymptote of x is equals to -2, our graph is increasing, as you can see there. Or when x is greater than -2, our graph is still increasing, right? So those are the solutions of x. When x is less than -2, our graph is increasing, or when x is greater than -2, our graph is increasing. So these are the solutions that we are looking for. Or someone can just say when x is the element of real numbers, but x is not equals to -2. So these two solutions are considered. Either you write this or you write these two here. Question 6.1, we are given p of x being equals to -3x squared. And 6.1.1, we are asked to give reason why the inverse of p is not a function. So our p of x is equals to -3x squared, right? So if we were to draw this function here, so if we were to draw this function, it's going to look like this. Because our a value is negative, so it means now that our function will face down. This is a parabola, by the way, so it's going to face down like that. So this is p of x. The inverse of this parabola will look like that, right? So the reason why this inverse of p is not a function is because if you are going to use a vertical line test and test all these values here, you will find that the vertical lines touch the graph twice, at this point and at this point, this point and this point, this point and this point. So the fact that the vertical line test touches the graph at 2 points, it makes the inverse not a function. So you can simply say p of to the power -1. So the inverse of p fails the vertical line test. Now 6.1.2, we are asked to place the restrictions of the domain of P so that it becomes a function. So remember that we said the inverse of P is not a function, right? So we want to make it a function now. How do we do that? We place our restrictions. So let's first draw our graphs. I'm just going to draw two graphs here. So when your P of x looks like this, right? And if you draw the inverse, it's going to look like that. So this is the inverse of P, and this is P, right? P of x. So for us to really place restrictions for this here, we need to eliminate a portion of the graph. So this is what we're going to do. We're going to draw just one part. So if we say we eliminate, it means now that if I consider only this portion of the graph, the other portion I don't consider. So if I consider it, so I'm going to write it here. So I consider this portion. So what does that mean? I restricted my graph to x being greater or equal to 0. So my x values start from the origin all the way to positive infinity, right? So I've restricted the graph. So now, how will my inverse look now that I've restricted my graph? So it means now that we're only going to consider this portion now of the inverse, right? So meaning that my graph is going to look like this. So it's going to have the inverse looking like that. So that is going to be my portion of the inverse, and this is going to be my P of x, right? So this is how I restricted my graph into x being greater or equal to 0. So that's what you need to write. Or I can restrict my graph to x being less than or equal to 0. So how does that look? You draw your graph like this, and now we're going to look at this portion here, because it's less than or equals to 0, right? So if we look at that portion, we need to draw it. So we're going to look at this portion of P of x, and now that we look at this portion, how will my inverse look? So means now that we're going to consider this portion of the inverse, this one here. We're going to consider this portion of the inverse. So now we're going to draw it. So it's going to look like this. So now we have restricted my P of x into this point. So that's how we do the restriction of our functions. In 6.2, we are told that in a test, Peter was required to determine the derivative of f, right? But he made a mistake and found the inverse of f, which is this one here. So we need to correct Peter. As it says, determine the correct answer given in a test. So we need to correct Peter by finding the derivative, not the inverse. So the inverse that Peter found was the root of x over 2, right? So we need to correct him. So what you need to do is we're going to square both sides. We know that this is the inverse, which you can write as y. So which means we square it, and we square the x over 2. So we're going to have y squared is equals to x over 2. Then since it's an inverse, we have to swap. So where there's x, you put y, where there's y, you put x. So which means here it's going to be x squared is equals to y over 2. Then we cross multiply. So it's going to be 2x squared is equals to y, right? So now we derive this. How do we derive y is equals to 2x squared? So we derive, it's going to be 4x. So this is the derivative that is required. In question 7.1, it says that an investment earns an interest rate of 12% per annum compounded every 6 months. calculate the effective interest rate of this investment. So we are told that the interest rate is equal to 12% compounded every 6 months, meaning half yearly, right? So it means half yearly, which is 1 over 2. So it's half yearly, right? So we are asked to find the effective interest rate. So it's going to be 1 plus I effective equals to 1 plus I norm over m to the power m. So we're going to transpose the 1 to the other side. We have I effective equals to 1 plus I norm over m to the power m minus 1. So we substitute, so it's 1 plus the 12% is going to be 0.12 divided by our half yearly, which is 2 to the power 2 minus 1. So our I effective is going to be equals to 0.1236. Then we multiply by 100. Our I effective is equal to 12.36. So this is our effective interest rate. 7.2. A company bought an equipment that depreciates at 7% on a reducing balance. How many years will it take for this equipment to be worth half its original price? So we are told that this equipment depreciates at 7%, right? And another thing that we need to note is that they say that the A is going to be half its previous price, right? So we're going to use our compound interest rate. Why? Because this is a reducing balance. Reducing balance is the compound formula, the decay compound formula. So we're going to say A is equals to P into I minus. So the formula is going to be A is equals to P into 1 minus I to the power n. And instead of writing A, we're going to write half P. So it's going to be half P equals to P into 1 minus I to the power of n. And then we divide out the P. We have 1 over 2 is equals to 1 minus I to the power of n. And our I is 7%, right? So it's going to be half is equals to 1 minus 0.07 to the power of n. So we want to find n. So we're going to use log. So it's going to be n is equals to log base 1 minus 0.07 and multiply with 1 over 2. Then our n value should be 9.55 years. So now 7.3, we are told that Kenneth invested 250,000 into an account that pays an interest rate of 9.5% compounded quarterly. 12 years after making the initial investment, Kenneth bought a house that cost 2,920,000. He used all that money he accumulated in his investment as a deposit for this house, and the bank granted him a loan for the remaining balance, right? The bank charged interest of the loan to 10.3% per annum compounded monthly. So the loan was for a period of 20 years, and first monthly installments were made 1 month after granting of the loan. So 7.3.1, we are asked to find the value of Kenneth's investment after 12 years. So what we know is that Kenneth made an investment of 250,000 rand, and the interest rate that was given was 9.5% per annum compounded quarterly, right? Cool. So now we're going to use the compound formula to find the money that he accumulated in 12 years time. So it's A is equal to P into 1 plus I to the power of n. His investment was 250,000 rand, and into 1 plus, so the interest rate is going to be 9.5%, so we're going to write it as 0.095 divided by 4 since it's quarterly, and to the power of 4 multiplied by 12 years. So the money that he accumulated for 12 years is 771,343.67. So this is the money that he accumulated in 4 years time. So now 7.3.2, determine the value of the loan that Kenneth obtained. So for us to find this, we need to first write down the money that he accumulated, which is 771,343.67. So this is the money that he accumulated in 4 years, right? The loan, for us to find the loan, we first have to find the value of the house. So the cost of the house is actually 2,920,000 rand. Bangumsindo man. Hey. So to find the value of the loan, we first need to identify the cost of the house, which is equals to 2,920,000 rand, right? So the loan will be equals to the cost of the house minus the investment that he accumulated. So it's going to be 2,920,000 rand minus the 771,343.67. So the loan that he got from the bank is going to be 214,856.334. So this is the loan that he'll get from the bank. So 7.3.3, calculate the monthly installments, or the monthly repayments rather, of the loan. So since we know that we're talking of the loan, right, means that for us to find the monthly payments, we need to use the present value annuity, which is equals to x into 1 minus into 1 plus I to the power of minus n divided by I, right? Our PV is the loan, which is going to be 2,148,656.334 equals to, we want to find the monthly repayment, so it's 1 minus into 1 plus So remember that the loan was for 10.3% compounded monthly, so it's going to be 0.103 over 12 to the power of minus 12 times 20 years. The loan was given for a period of 20 years. Divide by 0.103 over 12. Then we're going to cross multiply. So we will have 2,148,656.334 multiplied by 0.103 over 12 equals to x into 1 minus 1 plus 0.103 over 12 to the power of minus 12 times 20, right? And we're going to divide by this expression of 1 minus into 1 plus 0.103 over 12 to the power of minus 12 times 20, and also divide it here, so it's 1 minus into 1 plus 0.103 over 12 to the power of minus 12 times 20. So our x is going to be equal to 2148656.334 multiplied by 0.103 over 12 divide by 1 minus into 1 plus 0.103 over 12 to the power of minus 12 times 20. So your x value, which is your installments, would be 21,163.869. So these are the installments that is going to make. So 7.3.4, Kenneth paid off the loan at the end of 20 years. How much interest did he pay on the loan? So remember that the monthly installments of the loan was 21,163.869. So let's first find how much will he pay for the entire 20 years. So it's going to be x multiplied by n, which is equals to the 21,163.869 multiplied by the 20 years multiplied by 12, because it's going to pay for monthly. So then you're going to get 5079,328.568. So this is the amount that is going to be paying. So we want to find the interest that the bank made. So you're going to say 5079,328.568 minus the initial value of the loan. So it's 2,148,656.334. So the interest that was made was 2,930,672.234. So this is the interest made. Now, question 8.1, we are asked to find the derivative using first principle of this function here of f of x equals to minus 3 over x. So to find the derivative, our f of x is equals to minus 3 over x, and our f of x plus h is going to be equals to minus 3 over x plus h, right? So the derivative is equals to the limit when h approaches 0 of f of x plus h minus f of x divided by h. So it's going to be limit when h approaches 0. So we'll write f of x plus h. We're just going to write this expression here. So it's going to be minus 3 over x plus h minus, we're going to put this expression here. So it's going to be minus 3 over x divided by h. So let's first simplify this expression here. So it's going to be minus 3 over x plus h minus, the minus will multiply the minus, so it's going to be plus 3 over x, right? So we're going to find the common denominator, which is x plus h and x, and then this x plus h will cancel out this x, so it's going to be minus 3x plus, and this x cancel out with this one, so it's going to be 3 into x plus h. So if we simplify further, it's going to be minus 3x plus 3x plus 3h over x into x plus h. So this minus 3x and this 3x going to cancel out, so you're going to have 3h over x into x plus h, right? So we're going to write it here. Limit when h approaches 0, so it's going to be 3h over x into x plus h, right? Divide by h. So which is going to be the limits when h approaches 0. So it's going to be 3h of x into x plus h multiplied by 1 over h. So this h cancel out with that h. We remain with the limits when h approaches 0 of 3 into x plus h. So we're going to substitute this 0 here. So it's going to be 3 into x in x plus 0, and then we'll remain with 3 over x squared. So this is going to be our derivative. 8.2, we're going to find the derivative of 8.2.1. So the derivative of this problem here of 3x cubed minus 2 to the power of 2. So we're first going to expand, so it's d of x into 3x cubed minus 2, 3x cubed minus 2, and we're going to find the product. So it's going to be this multiplied by that. It's going to be 9x to the power of 6 and minus 6x to the power of cubed minus 6x to the power of cubed plus 4. So the derivative of 9x to the power of 6 minus 12x to the power of 3 plus 4. Adding these products here gives you this. Then now you can find the derivative of this problem here. So meaning that you drop the 6, so it's going to be 6 into 9x to the power of 6 minus 1 minus 12 into 3 x to the power of 3 minus 1, and the derivative of 4 is 0. So 6 multiplied by 9 is going to give you 54, so it's going to be x to the power of 5 minus 36 x to the power of 2. So this is going to be your derivative. 8.2.2, we need to find the derivative of this expression here. So we have y is equals to 2x cubed minus 4 over x plus 4 cube root of x, right? So the first thing is we need to write down our expressions properly. This expression, we need to write it properly, and this expression, we need to write it properly, right? So first thing we're going to do is we're going to say y is equals to 2x cubed minus 4 x to the power minus 1. So we're going to take this x to the top, and plus 4 multiplied by x to the power of 1 over 3. So how did I find that? When you have the cube root of x is to the power of 1, and this is 3. So this 3 is going to go at the bottom here, right? So meaning that's going to be x to the power of 1 over 3. So y is equals to 2x cubed minus 4x minus 1 plus 4x to the power of 1 over 3. So now we can derive. So we're going to drop this 3 into 2x to the power of 3 minus 1. Then we drop this minus 1, so it's going to be positive 4x to the power of minus 1 minus 1. And then we drop the 1 over 3 multiplied by 4x to the power of 1 over 3 minus 1. So the derivative is equal to 6x to the power of 2 plus 4x, so it's 4x to the power of minus 2 plus so it's plus 4 over 3x to the power of minus 2 over 3, right? So you can leave your problem like this, or you can simply write y derivative is equal to 6x squared plus so you're gonna drop this x to the power of minus 2. You have 4 over x squared plus 4 over, so you drop this also because the power is negative, so you're gonna have 3x to the power of 2 over 3. So this is your derivative. 8.3, so we are asked to determine the coordinates of the point of the curve of y is equal to 2 into 1 minus x all to the power 2, where the tangent at this point is perpendicular to this equation here. So if the tangent is perpendicular to this equation, which means now the m of t multiplied by the m of this equation, which is minus 2, gives you negative 1. So we're going to divide by this, so it's going to be m of t multiplied by negative 2 equals negative 1. Then we divide by negative 2, divide by negative 2. So the gradient of the tangent is 1 over 2, right? So when you have lines that are perpendicular, the gradient, the product of those gradient must give you negative 1, which is this point that I did here. So hence our gradient of the tangent, we know it's 1 over 2. So let's solve this problem here. So we now know that our gradient of the tangent is 1 over 2, right? And our equation, which is y is equals to 2 into 1 minus x to the power of 2. So let's first derive this, but before we derive, let's first find the product of this. So it's going to be y is equals to 2 into 1 minus x, 1 minus x, and the product is 2 into 1. This 1 multiplied by 1 is 1. This 1 multiplied is x minus x, and minus x plus x squared, which is 2 into 1 minus 2x plus x squared. So we multiply the 2 inside, you're going to get 2 minus 4x plus 2x squared. So if you write it properly, you have 2x squared minus 4x plus 2. So this is your equation of y. So for you to find Normally when you find the gradient of a tangent, you need to derive your equation of 2x squared minus 4x plus 2. So the first derivative of your function is actually going to give you the gradient of your tangent, but we're looking for the coordinates here. So we first derive, we're going to have 4x minus 4, right? And we found the gradient of the tangent being 1 over 2. So we're going to substitute it at y prime. So it's going to be 1 over 2 is equals to 4x minus 4. Transpose the 4 to the other side. We have 4x equals to 4 plus 1 over 2. And then we divide by 4, so our x value is equals to 9 over 8. So this is the x value. Then you're going to substitute this x value into your equation to find the y value. So we're going to substitute it to the original equation of y is equals to 2 into 1 minus x to the power of 2. So to find the y values, y is equals to 2 into 1 minus, you have 9 over 8 all to the power of 2. You're going to get a value of 1 over 32. So these are your coordinates, which is 9 over 8, sorry, and 1 over 32. So this is question 9. We are given a cubic function of f of x equals to ax cubed plus bx squared plus cx plus d, and we have a point of our x-intercept and our y-intercepts here, and we are told that q and r are turning points of f. So this is the graph below here that we're given, and we are asked to find, so in 9.1 we are asked to find the value of a, b, c, and d. So we are having our f of x being equals to ax cubed plus bx squared plus cx plus d, right? And we are given points. P is 0 and 6, q is 1 and 0, r and s is 3 and 0. So for us to find the equation of this cubic function, we need to use this expression here, or this equation, a into x minus x1 x minus x2 squared. So why am I saying x minus x2 squared? It's because if you look at the graph, the graph has an intercept here at x equals to 1, right? That intercept is also the turning point. Hence, you have to say x minus x2 squared. You have to square that. That square means that it has a turning point and an x-intercept at that point. So I'm going to substitute our x-intercept, which is 1 and 0 and 3 and 0, into the equation. So we have f of x equals to a into x. So we're going to start first with the minus 3 because it's the first intercept that doesn't attach itself with a turning point. So then the other intercept of 1 is also a turning point, so we need to write it here. So it's going to be minus 1 squared. So now that we have this, we're going to use a point which is our y-intercept to substitute it. Y-intercept when x equals to 0. So that point is 0 and 6. Why are we substituting this point? We want to find the value of a. So we're going to substitute it. Where there's y, we put 6. Where there's x, we put 0. So it's going to be 6 equals to a into 0 minus 3. And then 0 minus 1 squared. So it's going to be 6 equals to a into minus 3 and minus 1 squared. So we're going to have 6 is equals to minus 3a. Divide by minus 3, divide by minus 3. Our a value is going to be equals to minus 2. Right? So we're going to substitute that a value here to find our equation. So our a is minus 2, right? So it's going to be minus 2 into x minus 3, x minus 1 squared. So we have minus 2 into x minus 3. We're going to expand this, x minus 1, x minus 1 equals to minus 2 into x minus 3. And then we find the product of this. So it's going to be x squared minus x plus 1 equals to minus 2 into x minus 3, x squared minus 2x plus 1. Then we're going to find the product of these two here. So it's going to be equals to minus 2 into x cubed, this multiplied by that, and then the x multiplied by this minus 2, so it's going to be minus 2x squared, and the x multiplied by 1 is going to be plus x, and then this minus 3 times this x squared is going to be minus 3x squared, and then this minus 3 times this minus 2x is going to be plus 6x, minus 3 times 1 is going to be minus 3, right? So it's equals to minus 2 into, so you're going to collect like terms, so it's going to be x cubed, and you collect these two like terms, going to be minus 6x squared, and then these two like terms is going to be plus 7x and then minus 3, right? So the 2 minus 2 is going to multiply everything that is inside, so it's going to be minus 2x cubed plus 12x squared minus 14x plus 6. So this is going to be our equation of f, right? F of x, which is equals to minus 2x cubed plus 12x squared minus 14x plus 6. So our a value is equals to minus 2, our b value is equals to 12, our c value is equals to minus 14, our d value is equals to 6. In 9.2, we are asked to determine the x coordinate of the point of inflection of the equation of f. So we now know that our f of x is equals to minus 2x cubed plus 10x squared minus 14x plus 6. So we are asked to find the x coordinate of the point of inflection. So we have to find the first derivative of this, so it's minus 6x squared plus 20x minus 14. So we find the second derivative, which is equals to minus 12x plus 20, right? Then we equate the second derivative to 0, so it's going to be minus 12x plus 20 equals to 0. And then we're going to transpose minus 12x equals to minus 20, divide by minus 12, divide by minus 12. Our x is equals to 5 over 3. So this is the x value of the point of inflection. 9.3, for which values of x is the function increasing? So how we solve this is we need to identify the point where the graph is increasing, which, if you look at this graph, the point where it's increasing is between this turning point and that turning point. So this point, this portion of the graph, it's increasing, right? So we need to identify the values of x when this graph is increasing. So we're having our f. So f of x, our f of x is equals to minus 2x cubed plus 10x squared minus 14x plus 6, right? So we need to find the turning points because the graph is increasing between those two turning points when x is equals to 1 and the other turning point that is unknown. So we need to identify that turning point that is unknown. So we first find the first derivative, which is minus 6x squared plus 20x minus 14. Then we equate the derivative to 0, so if minus 6x squared plus 20x minus 14 equals to 0, then we divide by minus 2 all sides, and then we're going to have 3x squared minus 10x plus 7 equals to 0. And then we're going to find the factors of this problem here. So it's going to be 3x and x, then 1 and a 7, negative and a negative, to give us the middle term. So it's going to be 3x minus 7 is equals to 0, or x minus 1 is equals to 0. So we transpose the minus 7 to the other side. We have 3x equals to 7, or x is equals to 1. So this was the first point of the turning point, which was already known. So we divide by 3 both sides here, so it's x equals to 7 over 3. So this is the other point of the turning point. So now because our graph increases between these two turning points, so we're gonna say x must lie between the 1 and 7 over 3. So this is the point where our graph is increasing. So now we're going to do 9.3.2. says that k will we must find the values of k when f of x equals to k has exactly 3 real roots, right? So how do we find this? We go back to our graph, and we want to identify the values of k when the values of y, the roots of y are 3, right? So this is the first point where we have our roots of y, right, which is y is equals to 6. And this is the second point where we have the roots of y, which is y is equals to 0. And this is another third point where we have the roots of y, which is y is equals to we don't know, but we know that the x value of the turning point at this point is 7 over 3, right? So let's first find this y value at this turning point, and then we will identify the values of k. So we're having our f of x being equals to minus 2x cubed plus 10x squared minus 14x plus 6. So we know that the x value of the turning point at the other root is equals to 7 over 3, right? So we're going to substitute it in this equation here, which would be minus 2 into 7 over 3 cubed plus 10 into 7 over 3 squared minus 14 into 7 over 3 plus 6. So we're going to get 64 over 27. So this is the second y value, the turning point. So now when we go back to this portion here, I explained that we want the values of k such that the y values have 3 roots. So as I said here, the first root of y is equals to 6, second root of y is equals to 0. Now we found the third root of y is equals to 64 over 27. So what are the values of k when we have 3 roots from this point up to the last point? So we need to identify the value of x at the first point, which is equals to 0, and at the last point x is equals to 7 over 3. So you can simply say that k must lie between 64 over 27 and 0. Question 10. A farmer makes a rectangular enclosure for his sheep using 100-meter fencing. He puts a double layer of fencing on one side to stop the sheep from breaking through to the crops in the next field. A plan of his fencing is shown below. So as you can see, this is where he puts a double layer so that it prevents these sheep from coming through this fencing and eating the crops that are here. So this is the diagram. So A b is given as x, as you can see here, and we are asked to show that in 10.1 we are asked to show that the area of the land can be enclosed in this way, given by this formula of a of x is equals to 50x minus 3 over 2x squared. So for us to find this area, we need to first redraw the diagram that was drawn for us, and here we know it's a double fencing, and we know that the total length of fencing that was used was 100 meters, right? And we know that from this point to this point it's x, so this is a, this is b, and this is c, this is d, right? And for us to find the other points, because here, since it's a double layer, we can simply say it's 2x, right? Because the first layer is x and the second layer is x, so you add both, it's 2x. And we need to find AD and BC now. So for us to find that, we need to say the total length. So for us to find AD, we need to say the total length of the fencing is 100, right? 100 minus the x, and the x, which is 3x, so it's 3x. But we want to find not only AD but also BC. So these are two dimensions that we want to find, right? So which means if we say length is equals to, so considering these two dimensions, is going to be 100 minus 3x divided by 2. So which means each dimension of AD or BC will have 100 minus 3x divided by 2. So which means AD is going to be 100 minus 3x divided by 2, and 100 here minus 3x divided by 2. So these are the dimensions. So now we need to find the area of this shape here. So our area is equals to length times breadth. So what is our length? Our length is 100 minus 3x so our length is going to be 100 minus 3x divided by 2 multiplied by our breadth, which is this portion here of x, so it's going to be multiplied by x, right? And to find that product, is we're just going to multiply the x inside, but before we do that, let's solve what's inside. So it's going to be 100 divided by 2 minus 3x over 2, and then multiply by the x. Then we have 50 minus 3 over 2x. Then we multiply the x. So if you multiply the x inside, we're going to get 50x minus 3 over 2x squared. So this is the area of the diagram that we drew above. So now we want to solve 10.2, which says that determine the length of AB. So this length here, which is written x, determine the length of AB if the enclosed area is at a maximum. So remember now, we found our area to be 50x minus 3 over 2x squared, and it wants us to find our length of AB, right? Our x value, so because AB is equals to x, right? So they want us to find it when it reaches a point of maximum. What I need you to note is that this equation it's actually an equation of a parabola, right? So this is a parabola. If you take a look, this is 50x minus 3 over 2x squared. So if you were to draw this parabola, since it has an a value that is less than 0, it's going to look something like this. So this is not the exact drawing, but it's just an example drawing, and it's going to have a point of maximum. This graph will have a point of maximum. So we want to identify the turning point of x actually. So this question wants us to identify the turning point of x. So you can simply say x is equals to minus b over 2a, which our b in this case is going to be this 50. So you're going to substitute 50 divided by 2, and our 8 minus 3 over 2. So your x value, you should get 50 over 3. So this is the x value, which will tell you the maximum point of the graph. Now in question 11, we are told that a group of 540 people with green or blue eyes were randomly selected to determine whether the green or blue eyes are dependent of the gender. The results were tabulated below. So 11.1.1 says that if a person from this group is selected at random, write down the probability that the person is a female and has green eyes. So looking at female and green eyes, so this is green eyes and this is female, right? So we're going to look at female and we're going to look at green eyes. So where do these points intersect? At these points here, right? So the probability of a female with green eyes is 147, right? And then we have to divide by the total number of people, which is 540. So this is your solution here. So now 11.1.2 says that after analyzing the results, a learner concludes that the probability of having green eyes is independent of gender. Is she correct? So we need to prove that. So we need to look at gender, which are these two, and eyes, which are green. But you need to consider only one gender. So if you want to look at males, just look at males. If you want to look at females, just look at females. So I'm going to scratch the males. I'm going to look at the female gender to solve this problem. So you can either use the male gender or you can use the female gender. You still get the same answer. So let's look at the probability of females. The probability of female is, so the total number of females is 240, right? So it's going to be 240 divided by 540. So that is the probability of females. So what is the probability of green eyes? Probability of green eyes is, so these is green eyes, this is green eyes. The probability of the entire green eyes is actually 330. So it's 330 divided by 540, right? So now what you need to note is we are asked to compare or analyze the independence of green eyes and females. So the equation for independent events is P of females multiplied by P of green eyes must be equals to the probability of females and green eyes, right? So we just found the probability of females. So I'm just going to write it here. So it's 240 divided by 540, right? Multiplied by the probability of green eyes. We found it also to be 330 divided by 540. So now what is the probability of females and green eyes? This portion here. So we can find it in the diagram, right? So the probability of females and green eyes. If we take a look at our graph, probability of people who are female, this is females, and green eyes, it's actually this one here. So it's 147. So it's 147 divided by the total number of people, which is 540, right? So we have to see if the left hand side is equals to the right hand side. So let's see that. So having our 240 over 540 multiplied by 330 over 540 is equals to 147 over 540, right? The product of the left hand side is going to give you 0.27 and the product of the right hand side is 0.27. So therefore the events are indeed independent. So both events are independent. 11.2, we are told that E and F are independent events. P of E is equals to X, P of F is equals to Y. And P of E and F is equals to 1 over 3. P of E or F is equals to 9 over 10. So we need to show that 30y squared plus 10 is equals to 37y. So this is how we're going to solve this problem here. So we are told that E and F are independent, right? So what this means now is, if you have the probability of E being given as X and the probability of F being given as Y, so the probability of E multiplied by the probability of F must give you the probability of E and F, right? So which means X multiplied by Y is equal to, so what is the probability of E and F? It was given. So the probability of E and F was given as 1 over 3, right? So it was equals to 1 over 3. So it means now here it's going to be equals to 1 over 3. So this can be equation 1. So maybe you can say X is equals to 1 over 3 we divide by the Y. So X is equals to 1 over 3y. So this would be your equation 1, right? So we also told that the probability of E or F is equals to 9 over 10. So let's write an equation that includes this union here. So the probability of E or F is equals to the probability of E plus the probability of F minus the probability of E and F, right? P of E or F, which is our union, was given as 9 over 10 equals to our probability of E is given as X plus our probability of F is given as Y minus our probability of E and F is given as 1 over 3. So in place of this X, we're going to put this value here that we found to be 1 over 3y. So X is equals to 1 over 3y. So we're going to substitute that. So we're going to have 9 over 10 is equals to 1 over 3y plus y minus 1 over 3, right? So what we're going to do here is we're going to remove the y at the denominator. So we're going to multiply by y all sides, multiply by y, multiply by y. So we're going to have 9y over 10 equals to 1 over 3 plus y squared minus y over 3, right? So what's going to happen is we're going to multiply by 3 all sides, multiply by 3, multiply by 3, multiply by 3, multiply by 3. So you're going to have 27y over 10 equals to 1, right? Plus y squared multiplied by 3, right? Minus y. So if you write it properly, 27y over 10 equals to 1 plus 3y squared minus y, right? And then we multiply by the 10. So we remove the denominator at the bottom, multiply by 10, multiply by 10, multiply by 10. So you're gonna have 27y is equals to 10 plus 30y squared minus 30y. So the common denominator, the common so we're going to have 27y is equals to 10 plus 30y squared minus 10y. So we're going to collect the like terms here. So it's going to be 27y plus 10y equals to 10 plus 30y squared. And then if you add these two here, you're going to get 37y is equals to 10 plus 30y squared. So we have proven the problem here. So 11.3, we are told that 13 learners must be seated on a bus where the seats are arranged as follows. So as you can see, this is the seating of the bus. This is the back row and this is the front row. So 11.3.1, if the learners are arranged at random, how many ways can they be seated? So we are told that the n is 13 learners, right? So now to identify the seating of these 13 learners at random, we're simply going to say 13 factorial, which will give you 622702080. So this would be the seating of these learners at random, 13 factorial. And then 11.3.2, if 5 friends insist on sitting in the back row, so if these 5 friends want to sit here in the back row, so the total of these friends are 5, so let's say it's 5 factorial, because they can sit on any seat as long as they fit as a 5 number. And then one learner who gets sick needs to sit next to the door, so which means this learner here wants to sit alone, so we can simply say 1 factorial. So if I write it properly, the 5 friends sit at the back row, so it's going to be 5 factorial, and this one learner is going to be 1 factorial. In how many ways can the learners be arranged? So there will be other learners that will be sitting at these other empty seats here. So these seats here, how many are these seats? There are 7. So these learners will also sit at 7 factorial. So what does that mean is all these learners will sit on each of these seats. One learner can sit on this seat, another can sit on this one, either of these seats, all these 7 seats. So to find the number of ways that these learners can be arranged, it's going to be 5 factorial, which is the learners that want to sit at the back row, multiplied by the 7 factorial, which is the learners that will sit on all these 7 seats, and multiplied by 1 factorial, which is the learner that wants to sit next to the door. So this is the solution of this problem here. So if you want to punch it in your calculator, you will get 604,800. So this is the solution of the number of ways that these learners will be arranged.